first of all, input and output. When we input means we plug something in, and then output is what we get out when we plug in a value. Correct, everybody? That's how input and output works of a function. So if that's true, then input is the domain. Domain is x values, which is input. Output is what we get out, or the range of the function, the y values. So everybody look at this line here. This is representing the line of a function, just some function. I'm not going to give it a specific function. I'm just telling you. So the x value, let's say that I give you an x value in the function is 2, and you plug in the x value into the function, which I'm not giving to you. Let's say you plug in 2 and you get out 3. So that would be the range would be a 3. Correct, everybody? The input is x, and the output is 3. Alright, well, an inverse function is actually just going the opposite of that. Your x value would be the input here, the 3 would be what you put in, and you get out a 2. So what happened here was the original function's xy point was 2, 3, and the inverse's function was 3, 2. Do you see how it was just x and y switch? So that is going to happen. An inverse function is switching x and y. That's the first thing you need to know. Well, if that's true, then look. This one's input is this one's output. This one's x, this one's domain is this one's range. The original's range is the inverse's domain. Do you guys see how that works? Okay, cool. So with that in mind, tell me, if these are a set of xy points here, well, in a relation, a set of points is a relation, what would be the inverse relation? Okay, perfect. Now watching me, I'm going to hurry and graph this. You wouldn't need to necessarily take notes on this part. So over 0 down 1, over 2 up 0, over 3 up 2 units, and then over 3 up 4, over 4 up 3 units. That is the original. Now I'm going to, in blue, I'm going to plot the points of the inverse. So over negative 1 up 0, over 0 up 2, over 2 up 3, and over 3 up 4 units. Now talk in your groups. That is a reflection over something. Can anyone see what it is? So talk your group. It's a reflection over what? Did you guys know? Reflection over?
Y equals x.
Y equals x, or the diagonal, right? So I heard some people say the diagonal. It's the reflection over the diagonal, which is the line y equals x. So just a reminder of how we graph y equals x. That's the same thing as 1x plus 0, our y-intercept is 0, so look, 0, our slope is 1, of 1 over 1, of 1 over 1, of 1 over 1. You got to be able to graph that accurately. Do you guys see? That's how they got it. You're right. An inverse is switching x and y points will create a reflection over the y equals x axis, a line. So if I stamped it across that line, it would map perfectly. Okay, so last thing we have to learn about inverses is, if you're given an equation, these are the steps you take to find the inverse. First, switch x and y, which makes sense, because that's what we did with our xy points. So that's your first step, is switch x and y in the equation. And then, so like looking at this one, we have y is equal to 2x plus 7. I switched it, so I have x equals 2y plus 7. Moving on to the second step, you're going to solve for y to get it alone piece by piece so that it's in the form y equals. Again, so the first thing I would do on this one to get y alone is subtract 7. So now I would have x minus 7 equals 2y. To get y alone, I divide by 2. And now y is alone. We've reached our goal. There's our inverse. Now, third step is to just change it to the correct notation so that we can determine which one's the inverse and which one's the original. So we write inverse as f negative 1 of x, but it's not, it doesn't have anything to do with the negative 1. That's just how they say inverse. So this just reads f inverse of x. So this is the inverse of function f. So then do you guys see how I took this and rewrote it like this? They are equally the same problem. You can write either answer is acceptable. The only reason I like to write it like this is because if I asked you to graph it, y equals mx plus b form is usually easiest. Questions on that? Pretty easy, right? Switch x and y, solve for y. So let's do an example here. So it says find the inverse, graph both the function and its inverse. And then it says, is the inverse considered a function? So let's go ahead. Here we have, starting with the original function, f of x is x squared minus 1. We would switch x and y. So we have x is equal to y squared minus 1. Then get y alone using algebra. What would be my first step? Add 1 to both sides. So I have x plus 1 equals y squared. Then what? Square root both sides. When solving and taking a square root, I need a plus or minus. So I have plus or minus the square root of x plus 1 equals y. So now our inverse, I'll write it underneath here. F inverse of x is plus or minus the square root of x plus 1. All right, now graphing the original, I'll graph it in black here. So remember, this is how we find the xy points of a x squared minus 1 graph. So remember, we start with the parent function x squared, plug in a -2, -1, 0, 1, and 2 into x squared. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. But then aren't we shifting down 1? So then we're going to subtract 1 from these. So here's my new parent function, here's my new official graph. It'll be -2, -1, 0, 1, and 2. Those didn't change. But we're going down 1 unit. So that'll be 3, down 1, 0, -1, 0, 3. So graphing that. -2 up 3 units over -1, 0, 0, -1, 1, 0, and then over 2 up 3. Here is my parabola. Now, the easiest way to find this one's xy points is to not go through and we could graph it because we learned how to graph that, but it's easier, much easier to take these points and just switch them, isn't it? Right? Because we're going to get there anyways. So we switch them and we get 3, -2, 0, -1, -1, 0, 0, 1, and 3, 2. So I'm going to graph those. Over 3 down 2 units, check mark. Over 0 down 1 unit, check. Over -1 up 0. Over 0 up 1 unit. Over 3 up 2 units. There's my sideways parabola. There it is. That's an inverse. That looks good. So now, question for you. The original, the black function, does pass the vertical line test. It is a function, correct? The inverse, though, does not pass a vertical line test. At each x, there can only be one y value. Do you see how it hits my pencil twice right here? Yeah. So it's not a function. So it says, is the inverse a function? No, but it still can be graphed. Okay, that's fine. It's not a function. Great. Moving on. Now let's do the domain and range of each of these. So here is the domain of the original. It's a quadratic. Look at the original, everybody. It's a quadratic. Don't quadratics have a domain of all real numbers? Yes. Now look, without even thinking, I'm going to go down and say, well, then the inverse's range is all real numbers. Much quicker than actually having to look at the graph, okay? Now let's look at the range of a quadratic that's been shifted down 1 unit. Isn't the range, what? -1 to infinity. If that's true, then the inverse's domain will be -1 to infinity, and we didn't even have to think about it. But it does all work out, because look at the red function. Its domain is -1 to infinity, and its range is growing down and up forever. But wasn't it just easier to look at the original and switch it? Yeah. Questions? So why did this become not a function? I'll tell you why. Look right here, the plus or minus. The plus is the top half of the square root. The minus, remember, is a reflection over the x-axis. So that's the bottom half of the square root. So the plus and minus is what's creating it to be not a function. Making sense. All right. Okay, now these examples you're not going to need to take note of. You're just going to watch because then you're going to practice on your own here in like 1 minute. So find the inverse and then is the inverse a function? So we switch x and y. So x is equal to y cubed, get y alone. So cube root both sides. Do cube roots get plus or minuses? So y inverse is equal to the cube root of x. We know what cube root functions look like. We graphed those last time. They look something like this. Is a cube root a function? Yes. It passes the vertical line test, doesn't it? Okay, moving on. So switch x and y. So we have x is equal to 3y squared over 4. Then what? Get y alone. Times by 4. So we have 4x equals 3y squared. Divide by 3 next, right? Then we would take the square root. So we have y inverse is equal to plus and minus the square root of 4y over 3. Is the inverse a function? Oh, what the heck am I doing? I'm going nuts up here. Going like a maniac. Okay, so it's actually 4x over 3. Okay. Question, is the inverse a function? No, because of the plus or minus. So basically, the only thing that's going to make it not be a function is the plus or minus. Because then we have a top half and a bottom half overlapping. Okay, awesome. So go ahead and do that one by yourself. Make sure you're good. Find the inverse of that. And then is the inverse a function? Go. The bottom one. And then I'll just have you tell me the answer. Plus or minus. Square root. 5x minus 5 over 2. Yes, and you could have split it up too, and then I heard some people saying, do we need to rationalize the denominator? I'm not worried about it. For inverses, I'm not worried about it. If you did, I'd give you brownie points on the test. That's extra, yes. Okay, so with that being the answer, definitely it's a no because of the plus or minus. Not a function. Okay, go to the homework, then I'm going to let you go like a maniac. This is problem number 5. It says, now I'm going to change the instructions. It says find the inverse, is the inverse a function, and then I'm going to have us find the domain and range for practice for the exam. So our first step is to switch x and y. So we have x equals y squared plus 2. So we'll subtract 2. X minus 2 equals y squared. Therefore, y inverse is equal to plus and minus the square root of x minus 2. Do you agree? So we know that the inverse is not a function. Now I'm asking you to find the domain and range of the original and the inverse. So let's do the inverse. The first domain and range here is going to be just f of x. And then this one's domain and range will be my inverse's domain and range. Okay, guys, if you think of a rough sketch of a quadratic, that's going to help you know the domain and range. The domain for all quadratics are all real numbers, so this one's range is all real numbers. Check, check. Moving on, this is a shift of up 2 units, is it not? And it's a smiley face facing upward. If that's true, my range will be 2 to infinity. Well, if that's true, then this one's range will be 2 to infinity. Pretty easy, right? Okay, let's do this one. Number 6. First step is to switch x and y. X equals y plus 2, so then subtract 2. So y inverse is x minus 2. So here's the original y. Here's y inverse's domain and range. Align, degree 1. All lines have a domain and range of, negative infinity to infinity. All real numbers, right? Well, if that's true, then this one's domain and range will also be all real numbers. Which makes sense. The inverse is a line too. Not too shabby. All right, so go do these ones on the homework. Focus. Okay, so we have started with quadratics and found the inverse, and in that process, while finding the inverse, we got a plus or minus square root. Now we have to take into consideration, now we're starting with the square root function, we're going to find the inverse in just a second. So first of all, I'm going to graph the square root of x minus 2. So just a reminder of how we learned that last time. We said the parent function is root x. So we created an xy chart from that. Plug in 0, we get out 0. Plug in 1, we get 1. We're going to plug in 4, we get out, the square root of 4 is 2. 9, we get 3. The parent function points are as such, and we're shifting right 2 units. So that means we'll add 2 to all of our x's, right? Okay, I'm just graphing this. So it's 2, 0. Over 1 plus 2 is 3, so 3 up 1. And then over 4 plus 2 is 6 up 1, 2, 3. So here's the square root function. Now let's find the domain and range of that. So the domain is 2 to infinity. My range is 0 to infinity. We learned how to graph these last time. Now let's use some algebra to find the inverse of that. So we switch x and y, so we have x is equal to the square root of y minus 2. So why don't we first square both sides? X squared equals y minus 2, since these cancel out, so we'd add 2. X squared plus 2 equals y inverse. So I'm going to write the inverse right here. So f inverse of x is x squared plus 2. Now watch me graph that one. So just watching, because I'm making a point here. Okay, looking at the inverse versus the original. The original is the red. My inverse is blue. We have way too much going on the inverse, don't we? Didn't the original just start with the top half of the square root? It didn't have a plus or minus. It only has the plus. Does everybody see? So we should not have the plus and minus of the parabola. So which part should I erase? The negative side. Good. So we got to actually erase the side because we have way too much here. It's not the full quadratic. It's only that much, that half of the quadratic. So we have to state that. Otherwise, if you say this is the inverse, you're saying it's the whole thing. So it's that is our inverse, but only for x values. We're going to always restrict with x. So this is our inverse for x values from 0 on, isn't it? So we'd say this is our inverse, but only for x values greater than or equal to 0. If we don't have that little x is greater than or equal to 0 in there, we have the wrong answer. So an easier way to find that, because if people always have a hard time finding this, let me show you. We want to know the inverse's domain. Well, isn't that this one's range? The original function, you guys, is this one's domain, right? You see how it says 0 to infinity? So then that's why it's for x values greater than or equal to 0. Does that make sense? So if you don't know how to find this restriction, go back to your original function, find the range, so that you can know this one's domain. So what if this would have been 2 to infinity? Then we would have said for x values greater than or equal to 2. Okay, good. Okay, so just watching, because these are basics, we're just going to make sure we're good. Find the inverse, state the domain and range of both is the inverse of function. So x equals 2y minus 1 squared minus 2, right? So we'd add 2, so we have x plus 2 equals 2y minus 1 squared. Then what? Square root. So we have plus or minus the square root of x plus 2 equals 2y minus 1. Add 1 and then divide by 2. Is everybody good with that? So plus or minus the square root of x plus 2. We added 1 and then we divided all of it by 2. That's our y inverse. Alright, let's do the domain and range. Domain and range. So of the original, it's a quadratic that's been shifted right 1/2 unit. Does everybody see why I say a half? Because of the 2 in front, right? So it's right a half unit, but that doesn't matter. Isn't our domain for all quadratics all real numbers? Well, then this one's range is all real numbers. And then it's shifted down 2 units, and it's a quadratic that looks like that. It's facing upwards, so isn't our range -2 to infinity? So then this one's domain is -2 to infinity. Not that hard. Right? Pretty straightforward. Okay, switch x and y here. X is equal to the cube root of y minus 1. Now what? Okay. So y inverse is x cubed plus 1. The domain and range of a cube root function is all real numbers. Do you guys remember that from last time? So this must be also all real numbers, all real numbers. Okay, writing this down because people have a really hard time with both of these. Finding an inverse for both of these for some reason is hard for students. You will be tested on it. So first step is to switch x and y. So we have x is equal to 2 over y minus 1. Now the thing is you're trying to get y alone, but y is in the denominator. How can we get y minus 1 out of the denominator? Multiply by y minus 1, right? I keep having people say multiply by the conjugate, but then we would have a y squared minus 1 on bottom, which made it worse, right? Okay, but it was a good thought. Okay, so multiply both sides by y minus 1. So now it divides out on this side, and we have an x times y minus 1 equals 2. Keep your goal in mind. Get y alone. Divide by x. Y minus 1 equals 2 over x. So then we will... So y inverse is 2 over x plus 1. Alright, now with rationals, if you can recall, finding the domain and range, the domain will be easy, the range will be harder because we'd have to know what this graph looks like. Graphing rationals was probably one of the hardest lessons of the year. So instead, we're not going to find the range using our graph. We're going to just use domain. So domain of the original. X can't be 1. So if that's true, isn't our domain negative infinity up to 1, union 1 to infinity? Well, then that's this one's range. Negative infinity up to 1, union 1 to infinity. Now, I don't want to have to find this one's range because we'd have to know what the graph looks like. So instead, I'm going to go down here to this one because finding the domain of a rational is really easy. It's the restriction. So x can't be 0, so then we know our domain on this bad boy is negative infinity up to 0, union 0 to infinity, so then I know this one's range. And we're done. And the inverse is a function, right? So yes. A rational is a function. Alright, let's do this. This one is the harder one for people. You'll see why in just a sec. Okay, first step is to switch x and y. So we have x is equal to y minus 3 over y plus 2. Now in this problem, we only had x equals 2 over y minus 1. We only had one y. You see how in this one we have two y's? Well, we got to tackle this a little bit interesting and a little bit differently. So first of all, we do need to get y out of the denominator. So I'm going to multiply both sides by, okay, so I multiply by y plus, yeah, y plus 2, sorry. I don't have room to write in, so it's kind of bugging me. Okay, so then these divide out, don't they? So then we have y plus 2 times x equals y minus 3. Now a lot of people from here say now divide by x, but we're trying to get y alone. Is dividing by x going to make it worse? Yes, it's going to make it worse. So here's what you're going to do. You have two y's. Anytime this happens where you have multiple of the same variable and you need there to be only one variable, what you're going to do is get everything with that variable on one side of the equation. And then you're going to get anything without that variable on the other side, because here's why. If everything on the right has a y, can't we factor out a y and now we only have one y? Yes. Okay, so get everything with a y on one side. Well, we can't bring this over unless this is distributed, so we distribute through. So we have xy plus 2x equals y minus 3. Now, once again, we want to get everything with a y on one side and anything that doesn't have a y on the other side. So let's subtract y from both sides. Subtract y from both sides. And let's get anything that doesn't have a y on the other side. So I'm also going to subtract 2x. So now those are gone. These are gone. So on the left I have this. xy minus y equals negative 2x minus 3, don't I? And now look, because everything has a y, I can pull out a y. Divide by y, divide by y. So then left is x minus 1. Don't just say x minus nothing, because that's a 1. And that's equal to negative 2x minus 3. So now to get y alone, divide by x minus 1. So don't forget how to do that. So there's your inverse. Y inverse is negative 2x minus 3 over x minus 1. And then the domain and range for those, the easiest way is to find the domain of this. X can't be 1, and x can't be negative 2, and then you know each other's range. Okay, go to the homework and do some of these. Okay, so it says right here, you know that for any function f, each x value in the domain corresponds to exactly one y value in the range. Well, that means each x only has one y. By definition, that's what makes something a function, correct? Yes. It passes the vertical line test. For each x, there's only one y value. Now, to make something a one-to-one function, to make it one-to-one, it is also true that each y value has only one x. So it's the opposite of that. So basically, isn't it true that if it's just backwards, they've just switched x and y, isn't it true that the inverse just has to qualify as a function as well? So basically, guys, x squared plus 2, does that pass the vertical line test? Is it considered a function? Yes. Yes. Is it considered one-to-one? No. No, because the inverse is not a function. Does everybody agree? Yes. Plus or minus would be in the inverse. So, no, it's not one-to-one because the inverse is not a function. So what about this? X minus 3, is it a function? Yes. Is it one-to-one? Yes, because the inverse is also a function. Do you guys see what one-to-one means? Okay, next thing, guys, I'm just going to tell you straightforward. Functions are considered inverses of each other if you do function composition both ways, and they both simplify to be x. So let me explain. I'm going to ask you on the test, are these two inverses shown me by function composition? So this is true. If they are inverses, f of g of x will simplify to be x. And also, g of f, the other way, g of f of x will also simplify to be x. It'll always simplify to be x if they are truly functions of each other. So what if we do one and it simplifies to be negative x? Then the answer is no, it's not inverses of each other. So let's do both of these. Rewrite this. This is f of g of x, is it not? So that means we're going to take g of x, which is this, and we're going to plug it into function f wherever there's an x. It replaces that x. So we have 1 over, this is the work you have to show on the test, 1 over x plus 1, and then we have a minus 1. Does everybody see how I plugged it in? Yes. Now simplify it to see what it comes out to be. Your work is your answer on the test. You would do your work gorgeously. That's 1 over x, because isn't 1 minus 1 0, which is really 1 divided by 1 divided by 1 over x. Dividing fractions is easy as pi. Flip the second and multiply it. So we have 1 over 1 times x over 1, don't we? Multiply straight across, so we get x. So that one worked. Now if this would have simplified to be something like negative x or something, we could just stop because it's a no. But we got to go on. We got to check the other one now. All right. So this one's g of f of x. So that means we're taking f of x and we're plugging it into function g wherever there's an x. So that's replacing that. So we have 1 over, and we have 1 over x minus 1 plus 1 out here. So let's simplify this. What would we do first?
1 over 1 over x.
So 1 over 1 divided by 1 over x minus 1. So dividing fractions is easy as pi. Flip the second and multiply. So wouldn't we have an x minus 1 over 1? We multiply straight across. So then that gives me x minus 1 plus 1, which is x. So they both simplified to be x. We've shown that. So the answer is yes, they are inverses of each other. The work is your answer. Does that make sense? Do we need to do another one? So we would take and go, with this one we would go like this. We'd take this bad boy, plug it in right there, right? And it would need to simplify to be x, and then we would take this bad boy and plug it in there, and it would need to simplify to be x, and if so, then yes. Can anyone tell me, based on what inverses do to each other, what this would simplify to be without doing any math? It's x, but then what are we doing with the 2? So the answer would be 2. Don't inverses undo each other? Well, if inverses undo each other, then one thing's going to undo the next, and we're going to get a 2. Does that make sense? Now let's say you didn't know how to do that. Find the inverse, and then we know how to plug things into each other, but they undo each other. F and F inverse plugged into each other would simplify to be x. Now we're plugging into 2. So do you see how we get 2? Sweet, that's the end of the lesson. You have about 10 minutes.